This YouTube channel is introducing various artificial intelligence models for classification, such as decision trees, random forests, k-nearest neighbors, and support vector machines. Additionally, they are sharing coding files to implement each of these models. And if you take a look, you'll notice that they all follow a similar coding format. As a result, this video will introduce coding that allows you to execute multiple artificial intelligence classification models simultaneously, rather than running them separately each time. The Jupyter Notebook file for this is available on GitHub, so you can download it and try running it yourself. There are various ways to execute classification models all at once, and here we will try using one of Python's fundamental data structures, the dictionary. First, let's briefly understand what a dictionary is. A dictionary is composed of key-value pairs. For instance, if we have data with names and ages, like Jenny being 20 years old and Ella being 31, we can store this data in a variable called D1, using colons to separate names and ages. We can observe that the type of D1 is a dictionary. When we print the key and value, we can see that Jenny and Ella are keys, representing 20 and 31 as their respective values. Moreover, by entering data in a similar format for John age 26 and Tom age 29, we can add new information to the D1 dictionary. Using the for loop and the items command, we can extract key value pairs one by one. Furthermore, in this coding example, we will work with a red wine quality dataset. This dataset contains both the chemical properties and sensory evaluation scores for 1599 samples of red wine. Specifically, among the 12 columns, 11 represent chemical characteristics of red wine, such as pH and acidity, forming the X data. The sensory evaluation scores are used as the Y data. Using this dataset, we will create code that simultaneously runs various artificial intelligence models to predict sensory evaluation scores from the chemical properties of red wine. In order to perform coding, we'll start by importing libraries like NumPy, Pandas, min-max scaler for normalization, as well as the train test split and metrics libraries. Then we'll apply Kfold cross-validation. In this context, we'll work with 4 classification models: decision tree, random forest, k-nearest neighbors, and support vector machine. Next, we'll load the red wine Excel dataset and store it in the variable df. Using the head command, we can display the first 5 entries of the loaded dataset. This will allow us to verify that the red wine dataset has been loaded successfully. We assign the sensory evaluation scores from the red wine dataset to the Y data. The chemical properties of the red wine are normalized using min-max scaler and assigned as X data. As a result, as shown here, you can observe that the X data has been transformed to values between 0 and 1. Afterward, we divide the dataset into a training set and a testing set in an 8:2 ratio. Through this process, we can see that the initial 1599 X data entries are split into 1279 training data and 320 testing data. In order to simultaneously run 4 classification models, decision tree, random forest, k-nearest neighbors, and support vector machine, the names of each model were designated as keys, and their respective libraries and hyperparameters were assigned as values. This structured information was then organized into a dictionary named models. Then, as explained in the previous slide, using the for loop and items command, each model is loaded, trained with the training data, and evaluated with the testing data. Afterward, by comparing the predicted sensory evaluation scores with the actual scores, we can obtain the accuracy for each of the 4 models all at once. Furthermore, by using the Kfold command, we can perform Kfold cross-validation. As shown here, by setting the number of splits to 5 using n_splits and using the cross_val_score command, we can obtain accuracy scores for each of the 5 repetitions and the average accuracy score. In this manner, we have looked at coding that utilizes the dictionary structure to simultaneously run various artificial intelligence classification models.